Hello and welcome everyone to another episode of Algorand Developer Office Hours. I'm your host, Ryan Fox. I am developer advocate here at Algorand, and I am thrilled to be joined today by Aaron Turner. He is a developer at Yieldly.Finance, and he's building the first DeFi suite deployed on the Algorand mainnet. So Yieldly recently participated in the Algorand Foundation's Asia Accelerator earlier this year. They also recently released a no-loss lottery game and are working towards multi-asset staking and cross-chain swapping. There's a whole lot to unpack here today with Aaron. He's got lots of code samples and many demos to share with us as well. So with that, welcome to the stage, Aaron. Welcome to Developer Office Hours. Go ahead and introduce yourself. Tell us why you're building on Algorand, where in the world you're joining us from, and then let's hear more about Yieldly.Finance. Welcome, Aaron.
Thanks, Ryan. So we're calling down here, both me and Alexander calling down here from Sydney. So it's getting a little bit late for us. Everything explaining as to why we're building on Algorand and everything else. It's going to be explained in the slides. In today's session, we're going to be covering the ins and outs of how we built Yieldly. So this session will feature several tech demos and will basically proceed as follows. So first, we're going to be commencing with an intro of Yieldly and myself. Second, we're going to unpack some of Yieldly's first generation suite of products and go a bit behind the scenes as to how some of these products work. Third, we're going to examine the no loss prize game and the staking pool products. Then we're going to be going into how the team has worked around some of TEAL 3's constraints, because our products were initially built on TEAL 3, whilst we're launching our first generation of our product suite. Next, we're also going to be then discussing the TEAL 4 improvements in the context of Yieldly's next generation of products that we'll be bringing out. Six, we'll be exploring some of what's in the pipeline for Yieldly in the future, and then we're just going to go over a bit of a Q&A. Keen to hear some of the community's questions and answer them as best as I can. So with that in mind, let's get into it. What is Yieldly? So Yieldly is the largest DeFi protocol currently built on Algorand. Our core objective is to empower users to exchange digital value without friction, gas inefficiency, or security risk. We're backed by some of the top VCs in the space and audited by market leaders. Our first generation of products launched in June, which helped deliver mission-critical infrastructure in the form of delivering the first staking pools for Algorand standard assets, the first interoperable bridge connecting the Algorand and Ethereum ecosystems, and also the first no-loss prize game built onto Algorand. Yieldly has already welcomed over 5,000 users onto our platform. We've got over $30 million US dollars worth of total value locked into our system. And we have over 450,000 transactions on our staking and no-loss prize game escrow as of right now. So we're slated to become one of the major infrastructure players for the ecosystem, and our team has already commenced on the next critical build cycle, which, among other things, will include some new products such as an AMM. All right, so who am I? So I'm the current CTO of Yieldly. So I am primarily responsible for the tech development, especially very hands-on with the smart contract and the smart contracts and the supporting software around that. I'm also a PhD candidate for the University of Technology, Sydney, and I've got a background from my undergrad in computer systems engineering. I've been coding in the crypto space since around about 2018, but I stumbled down the blockchain rabbit hole just a little bit before that. I am also currently part of the team that competed in the EOS Global Hackathon Grand Finals, which is True Origin, which really helped cement my passion for blockchain after that. Getting to the first of Yieldly's products, the No Loss Prize game, essentially what it does is it just allows you to stake your algo and accrue some Yieldly tokens as a reward, as well as being a part of the draw of winning the algos that are accrued in the escrow's rewards. So to date, we've actually run 9 successful prize games. So how does the no loss prize game work? This doesn't just encapsulate the no loss prize game. This is actually the architecture of all of our contracts, which includes our staking pools. So so what's shown on the side is essentially just a high level overview of how our contracts are more or less structured. So from what you can probably see from our slides, there's a lot of moving parts, not just for the lottery, but our staking pools also. With many of the contracts just all having a part in making the Yieldly product currently what it is. So many of the design decisions around the structure of our contracts and large amounts of the large amount of contracts required was initially due to our contract size limitation prior to AVM 0.9 coming out, because it came out after we had released our contract. So, but more on that a little bit later. So essentially, how it works is our prize game controls all of the system's main aspects for itself, which includes the stake logic, the withdrawal logic, and the claiming logic. The same also applies to our Yieldly staking contract. And also, it has some basic levels of security built into these contracts, but the main layer of security is actually our proxy contract, and we rely on that to really lock down any type of, I guess, bad transactions that someone might be trying to execute. So it's a bit like a guardian, if you will. The distribution rate and round tracking contracts that you can see that are connected in parallel. Basically, the distribution rate contract determines the rate of rewards that will be released every cycle, which in this case, every 30 minutes, it determines how much rewards will be unlocked and made available to everyone, as well as the distribution ratio between both the prize game and the Yieldly staking pools. The round tracker that you can see on the left, it just allows the prize game to increment a round counter. It did originally have a more fundamentally important role to play in the overall system, but after a few iterations, it really just became more of an informational type of contract. So that's pretty much the high-level overview of our contracts explained there. And currently, the prize game runs weekly on a cron job, on a cron machine that we host on our AWS services. The cron machine has two main ingredients. So the first is randomized data from Chainlink's VRF system. So this just allows us to get a truly randomized number that's verifiable on chain. And then after that, what we use our own special indexer and selector programs, which essentially just allows us to select the winner and with the random number and run our lottery winning program. So yeah, the winner will get their algo by having their state in our contract mutated. So we don't directly send it like in a payment transaction to the user. Instead, what we do is we just modify their local state in the contract to just now include that algo into their account, which means they can just simply withdraw it. It sounds fairly simple, but that was actually quite a complex design and tech build to implement. Moving on to our staking pools. So these are the first staking pools in Algorand. So our first generation of pools just allows you to stake your Yieldly and accrue rewards in the form of Yieldly, in the forms of some algo that we distribute to the staking pools from the lottery win, as well as additional Yieldly. So obviously our pools create a utility function for our native token, but they also open the Algorand ecosystem up to reward generating opportunities. So hence why our staking pools have become an object of desire for other ASA projects and partners. And we've taken a bit of an ecosystem approach to this, turning what could potentially be competitors hopefully into collaborators with our partner pools that are slated for Q3 release in 2021, which you'll see in the timeline a bit later. So not like our no loss prize game, the staking pools have three main functions. Essentially, you can stake, withdraw, and claim. And just like the prize game, it's very tightly coupled with our distribution scheme, which we'll get to when we go into the technical demo, and you'll sort of see what I mean by that. All right, so talking about the rewards distribution system. So let's just unpack Yieldly's reward distribution scheme. We'll first discuss things at a fairly high level, and then we'll just take a bit of a deeper dive into the code to see some of the issues that we've encountered and how we worked around some of the issues that we came across. So it's useful to understand what compromises we sort of had to make to ensure the contracts could work and launch the first staking pools into the Algorand ecosystem. So I'd like to take the time here to explain in detail how the system works from a high level. Then we can start to take a bit of a dive into the code and to see how we worked around some of the technical issues that we were facing, some of the things that we discovered in our time developing, and just talk about like what sort of compromises we had to make to ensure that the contracts could actually be the first, contracts involving staking pools on the Algorand ecosystem. So how does the rewards distribution work? So I know that this image might not be the easiest thing to see, but we do provide these slides to you guys. They'll be free and available to download, so you'll be able to zoom in and sort of unpack it a bit more yourselves. But let's just sort of discuss it more from a high level. So how does it work? So we utilize a system that's called a staking shares reward system. So basically, as long as you have shares into the pool, you have claims to the pool's rewards. So to those who've played with similar systems, i.e. Ampleforth's liquidity pool staking rewards program system, it's probably some developers know it as Ampleforth's token geyser, you'll probably likely already know where I'm going to start heading with this. So the next thing that's typically asked is, how do you accumulate these so-called staking shares? So beyond just staking into it and building staking shares, how it actually works is, so shares are a product of two factors, which is how much you have staked and how much time you spent in the pool. So the more time and the more stake that you have in the system, the more shares that you'll start to accumulate overall. Your shares are then divided by the global amount of staking shares, which is basically just the entire sum of everyone staking shares that is participating inside of the pool. And then your ratio is just times by the amount of available rewards, which is in the pool. At which point, after you claim, your staking shares will then be reset. So, the next question that usually comes up with that is, how are my staking shares calculated when claiming my rewards? It's basically just two basic equations that essentially govern the system. We'll go into more detail of that in the tech demo, but basically it's your global staking shares and your user staking shares. So your global staking shares is simply just the previous amount of staking shares that have accrued, plus the amount that you had staked times, plus, and then in brackets, times, your stake amount times how long you've been in the pool. So it's a pretty simple concept from a high level. And as you can see in the diagram, it sort of explains how that works. So people might ask, why this particular type of reward system? So this reward system was chosen for a variety of reasons, but I'll narrow it down to the main two, which is just experience, so the depth of understanding of this particular type of staking system, and time. So, just myself and a few others involved in the development of this product. We're just intimately familiar with the global staking shares, rewards distribution scheme. So ultimately, when push came to shove and ultimately we had to get this product over the line, we ultimately chose to go with what we were most comfortable with, which happened to be this particular reward system. So that's the rewards distribution from a high level. And obviously, as I said before, if you want to look into it, you can. We have information online, and we also now have this slide that's available to everyone. So before we jump into the code, I just wanted to acknowledge some of the problems that both the team and our community have pointed out with our existing reward scheme. So no approach is really above criticism, and Yieldly is no exception. I just want to make it clear that we're listening, adapting, and overcoming a variety of issues that have been present since day one. So some of the big stuff that people point out is one is the lack of auto compounding. So this is a great point because it's the same token staking pool. It definitely should have the ability to auto compound, which is something that we've acknowledged and have actually implemented in our future generation of contracts. The so-called draining of rewards. So it's just an unfortunate side effect that's of the staking share system that's just compounded on from the fact that rewards used to only be updated every 7 days, which was since mitigated by making the rewards be released every 30 minutes instead. But still an issue. The next is just 24 hours is too long for your own staking shares to update. And, we just all agree on that. So we've already thought of better staking reward systems that we're already building and starting to put into place. So, don't stress. So when we were first building and conceptualizing the contracts, we actually started with the current implementation being TEAL 2. So that being said, TEAL 3 was right around the corner. And whilst TEAL 3 did come out with some new features, such as the ability to see an account's minimum balance, a feature that we now pretty much heavily rely on for our reward calculations to be accurate. Despite these improvements, it was far from what I could still consider to be a viable way to start building smart contracts on the blockchain due to some of the issues that we encountered. So first of all, it was the contract size limits were a little bit too low. So 1 kilobyte, doesn't sound like a lot, and it, really wasn't considering some of the logic that we had to put into place. And writing TEAL contracts requires quite an extensive defensive approach, which requires a lot of repeated safety and security checks that are spread throughout the program. So, for some perspective, when I initially wrote the contracts as a basic, staking and withdrawing for the algo, just for the algos, it basically was just one contract. When I started to include ASAs, it bloated out to 2, so on and so forth. And then eventually, when you add, take into account all the security that needed to be added, you can see how it started to blow out into this big, massive multi-contract architecture like you saw above. The second is overflows. So, 64-bit numbers sounds like a lot until you start dealing with numbers as large as ours. Dealing with 6 decimal places of precision and working with numbers up into the billions. It doesn't leave a whole lot of wriggle room when you're trying to do such intense calculations, like in terms of utilizing second by second staking shares updates, which as you'll be able to see in the code, the numbers can start to get quite large when you start using that, and it can result in overflows and end up breaking the system. So that's something that we had to work around and avoid. And most importantly, the biggest one is probably no recursions or script jumping. So the inability to jump up and down the program was a major factor into why we couldn't optimize the program even further to try and reduce the size of the contracts and keep more of the functionality more contained inside less contracts instead of having to blow out into more. But obviously, a lot of these issues have been addressed, but we'll talk about that in the TEAL 4 segment. All right, so despite all the previously mentioned issues that Yieldly has had with the implementation of our contracts using TEAL 3, I would like to focus on the positive and creative aspects around this, specifically on the workarounds and compromises that we made to still deliver the first DeFi platform on Algorand. So, as shown on the slide and mentioned throughout the presentation, we had to be quite creative and flexible in our development cycle. So, so let's just move on to the technical demo now. So, basically, just to pretext this demo, this is not this is not directly one-for-one the code that had been deployed in the mainnet. Instead, what I have done is I've actually extracted snippets of the code and reworked them slightly so as to make them demoable in this particular context. So whilst there are many of these particular functions are closely related to the ones deployed on the mainnet, I've actually, in the way that I've modified them, it's to reduce some of the complexity to be able to test them in the way that we're about to see, because the original ones are part of more complex contractual transaction groupings, and it's not really worthwhile showing all of that. It's just more it'd be more worthwhile just to show the core concepts of what Yieldly is bringing into its staking pools. So I'm just going to show you some of the key things that we needed to work through in the TEAL 3 contracts and show off some of the design decisions that we made in order to allow our logic to work on TEAL 3. So the 3 main things I'm going to be going over is the staking logic, the withdrawal logic, just with a few minor changes, and the claiming logic. And lastly, also just the reward system that sort of binds all of these concepts together. No loss prize lottery and the staking pools share much of the same code. We're pretty much going to be hitting 2 birds with 1 stone by showing what we're about to show. So I'll also show you how just small changes in the program can cause issues such as overflow to arise. So we'll get to that when we move on to when we talk about the claiming function. All right, so let's just get into the demo here. So I've actually pre-prepared some scripts for you. So essentially what I've done is I've extracted all the code, made it demoable in this context. And what I've done is I've gotten some of the key ways to deploy and interact with the contract into their own bash script files. So, you're not just going to see me typing out like a bunch of gold commands on the screen. Instead, what we're going to do is we're just going to keep it to just a TEAL code and just run these whenever we need to perform certain operations. So the first one that we need to do to start with is, let's just start with creating the actual application. So just to prove that this is an actual application that we're working live with now, I'm just deploying that. Okay, this is deploying on the test net, which is why it's just taking a little bit. Once we have that, we can then chuck the app ID that we get from this. Beautiful. We'll be getting the app ID. We'll chuck it into the other bash script files, and then we'll get stuck in. So because the escrow hasn't really changed, I don't need to opt the escrow into anything. So we'll be able to just jump straight into the staking and claiming functionality. So I'll just save that into here. Save that into here. Just make sure, yep. All right. Unlock. Even though we're not doing it, just chuck in withdraw. Oops. All right, and the locking function. All right, so the first thing we're going to do is we're just going to lock some rewards into the staking pool. So it's as simple as just running the locking script. Here we go. It's just locking 50 million Yieldly into the staking pool. So there we go. So I made it so that it also just returns the application state so we can see clearly what's happening at the end. All right, so yep, we got our 50 million locked in there. Our global time has been initiated. Our local time, users time has been initiated. And now we have nothing staked in the pools, no shares, nothing. So we got a fresh new account ready to get, fresh new application ready to go. So let's just get stuck in. So the way that this demo is going to work, I'm going to start by just sending in 1,000 Yieldly, so to speak, like 1,000 test Yieldly, just so that we're able to see how the contract behaves after you go to stake in more Yieldly again, like how does it compound the global staking shares and all that sort of stuff. So let's just run the staking script just to get some into the program. Let's just get through that. All right, perfect. So you can see the state is mutated. So I now have 1,000. We divide this by 10 to the 6 because we got 6 decimal places into our test Yieldly ASA asset. So you divide this by 10 to the 6, you get your 1,000. So we got 1,000 stored in the global state, 10,000 stored in the users amount, and the staking shares are both 0 because they haven't accumulated anything yet. So this is when we start to get into the next part of the demo, which is how do we see this getting updated and how does it work? Okay, so let's just jump into that. So what I'm going to run now is I'm going to run the TEAL debugger so we can actually step through the code step by step and just see how it works in action. Okay, so it's running the debugger, perfect. So now let's launch the actual, there we go. Okay, so I've already got this set up so that we'll just jump straight to there without jumping through the entire script. So here we go. All right, so we jump straight to the staking function because everything else around this is just fluff. So we're just focusing on the main thing here, which is the staking. So how does the staking function work? Or by extension, how do the staking, withdrawal, and claiming functions work? Well, basically they work in 2 parts. First, they update the global state. Then they update the user's local state. And what we do first is we update the global staking shares first before mutating how much stake has now been added to the pool, just to get an up-to-date representation of the current global staking shares and user staking shares up to that point. So what I'm going to do is I'm just going to step you through this. To start off with, we're going to go into this byte called GA. So basically, this is just the application's global state variable called GA, which in which is just a shortened version of global amount. We had to do this to save some space in the contract. So other creative ways that we had to work around the 1 kilobyte limit. Inside of this byte GA, what we're going to do is we're going to get the variable that is stored in there. So this is the previous amount, which if you can see, well, here we go. If you can see here, the previous amount was this 1,000 times 10 to the 6. So we should get the exact same number here. So once I get it from the global state, there we are. It's just been loaded into the stack. What I'm doing is I'm going to be storing it into the Scratch space. So because most of you, it seem to be familiar somewhat with developing on crypto. I'm not sure about the exact experience of developing on Algorand, but just to give a quick and brief explanation on what the Scratch space is. So basically, the Scratch space is just this like global memory that you can load your variables to and access different points in the contract without having to modify or go through the stack or having to keep track of what's happening in the stack. It's just an easy way to store and load your variables. In the context of what we have done and how we've done it, we initially had it so that it was a bit more, the word that I'm looking for escapes me, but it was like, going from like 0, 1, 2, 3, 4, 5 in a much more straightforward manner. You sort of see how we go from like 1 to 8 to 2 and a bunch of like random numbers that are spread throughout. That basically was just because of us going through the development cycle and going through so many iterations of the contracts and trying out so many different things. You start to lose a bit of track as to what's happening and where you're storing the variable later down in the script when you stored it early and you're overriding each other. It became a nightmare. So it became easier just to sort of go and using a wide array of numbers and just random numbers, picked, basically just off the top of your head, just to like sort of, I guess, help spread out, the complexity of trying to keep track mentally of like how many storage locations you're using and make sure you're not overriding each other. So that was pretty much a justification for why it goes from like 1, 8, etc. So next, what I'm going to do is in this particular example, you can see this commented out piece of code here. Essentially, what we're doing is we're trying to get the amount of seconds that have passed between the last time the global time was updated to the current timestamp. So in this case, we're simulating 5 days. So we're getting 5 days worth of seconds. So in this case, it's 432,000. Next, what we're going to be doing is we're going to try and convert that into a single digit number of how many days have passed. So converting it from seconds to days. So what we do is we divide that number by 86,400, which is the amount of seconds inside of a day, which like if you're developing in the way that I am, this number is pretty much going to be burnt into your skull like it has for me. So what we do is when we do the divide operation, we get the amount of days that have passed, which in this case has been 5, and then we store that into the 8th, or in this case, 9th element of the Scratch space. So what we do after that is we then load that variable back in. So this is what I'm talking about, how like sometimes we store it and then load it immediately after. We had some other logic that we're playing with in between. And ultimately, when we went through the many iterations and shortened it down, we removed a lot of stuff, which meant that some of the variables, whilst they're not necessarily out of place, it's just they haven't been updated to reflect our I guess our current development style that we do for modifying TEAL global and local state elements. So you'll see that a bit later on as well. So we load the 8th element of the 9th element of the Scratch space, which is the number 5, which is how many days have passed. We then grab the amount of stake that was in previously, which in this case was 1,000. Stake, I mean amount. We then times those two numbers together, which gives us the amount of the amount of staking shares that we're now going to append to the previous amount. So how do we do that? Well, we essentially grab the previous staking shares, the global staking shares variable, very similar to the way that we do it with GA. We get it. We load that onto the stack, which in this case, it's going to be 0 because this is going to be the first time that we're updating the staking shares ever for this application and for the user as well, which you'll see in a bit. We then append those two together and then we store it into the Scratch space. And then what we do is we just simply load that new variable into the global staking shares global application state. So we just simply load in the GSS byte, load in the amount of staking shares that we wish to update it to, and then we simply put that into the application's global state. So pretty simple stuff. The amount is pretty much handled the exact. The amount is updated in a similar fashion, except it's just much more simplified because you're just appending the amount. So the way that this works is we load the GA variable back onto the stack. We then get how much is in the global amount, which is the same number that we saw before, which is this number right here. Then we grab from the second transaction, because this is a group transaction of two transactions. The first being the application call that you're seeing here. The other is an AXFA transaction for the fake Yieldly token. So in the second transaction, which is what I'm specifying here, so the group transactions in the first element of the array, which is the second element of the array, which is the second transaction in the group transaction. I'm asking for the asset amount that is in there, which in this case, when loading that in, is another 1,000 Yieldly, because I haven't changed that. I'm then appending those two numbers together, storing it into yet another just random scratch space. And then I'm just exactly the same as what we did with the global staking shares that you saw up here. I'm loading that variable in and then storing that in the application's global state. Very simple stuff. With the global time, what we're doing here is what we think is a very clever way of handling how to track how much time has passed since the last time a last 24-hour period had passed. What we do is we then load that eighth variable, the ninth element in the scratch space, which in this case is 5. We then also load in an integer of 1. So what we're doing here is we're essentially doing a comparison of how many days have passed how many days have passed over 24 hours. So obviously, if it's less than 24 hours, the way that Algorand works is that if you have a number that's less than 1 or a decimal place, it actually floors the number down. It doesn't round up. It actually floors it down. So what happens is that if it's actually less than 24 hours, the division that happens up there will actually result in this being a 0. So then what happens is that this won't update, and it will basically hit this if this check fails, this greater than equals to comparator fails, and basically it will just skip this entire process. But in the case of what we have, it's actually larger. In this case, it's 5 days larger. So we're able to then update the global time. So what we do here is and this is the way that we have been coding all of our stuff going forward, is we load the GT variable at the top of the scratch space, on top of the stack space, and just leave it there. We deal with that later. And then what we do is we also then load the GT byte again, except this time we're actually getting the amount that is stored inside of it. After that, we load how many days have passed again. We then, you probably see where we're starting to go with this. We times that by the amount of seconds in a day, which will be our original number of 432,000, which is the number that you saw up here. And then we store this we append that to the previous global time, and then we put that into the application's global state. And that's pretty much updating the application's global state in a nutshell. So I won't go into too much detail about the user's local state, because it's pretty much handled the exact same way. So you have your user amount here, which you're loading it in. Then you're storing it in the scratch space. So we're now overriding the previous variables because we don't need them anymore. We're then calculating the exact same stuff. So 5 days have passed since that particular user has done it. We're dividing it by how many seconds in a day that it has been, yada, yada, yada. And we basically get a lot of the exact same variables and amounts that you saw previously. So what ends up happening is, if we were to step through this, for example, and get the user staking shares, you'll start to see that the user staking shares, let's just load that back in. The user staking shares is looking a lot like the global staking shares, which is how it's supposed to be. If they're the only user in the pool, it's basically a closed loop system. Everything needs to sum to 0 for the system to work. And the way that we've designed it is so that the system will always sum to 0 in pretty much all circumstances. So we update the user staking shares. We update the user's amount pretty much the exact same way. And then we update the user's time pretty much the exact same way as well. So you can start to see like a bit of a pattern as to like how this works. Obviously, we can't really count this as repeated code because updating someone's local state versus updating someone's global state is still technically a different process. But what you'll start to see now is after we finish this off, this should just finish successfully, which is correct. So all those numbers, I'll just, for the sake of completion, we'll just run that. Not as a dry run, but as a send that to the blockchain, to the testnet, and we'll just have a look at the numbers, and you should start to see the exact same numbers appear. There you go. So the user amount has been updated to 2,000, which is what we saw appear in the stack. In the global amount sense, because that's the one we stepped through. The global staking shares updated to 5,000, which is what we saw, and so on and so forth. So, and what you'll be able to see is that all the values line up. They're exactly the same. So that's how it's meant to be because we want it to be closed loop. So just to move along here, in terms of like withdrawing is pretty much handled the exact same way. The only difference being, and I'll show you guys down here. Here we go. Yeah, so the only difference between the staking withdrawal function is just simply the way that we handle the amount. So if you have a look here, when we update the amount, instead of summing the amount to the previous one, we're instead just subtracting it. So minus, other than that, this is pretty much the exact same function. So we won't step through it for the sake of time. But what we will do is we'll step through the claim function because that is quite important. So pretty much what we're going to be doing here is we want to lay claim to the entire amount because obviously we're going to be the only people in here. If you have a look at how the math should play out, we should have 100% claim into the entire, Yieldly reward pool. So what we want to do is we want to unlock the tokens from the token Yieldly lock to the token Yieldly unlock. So we'll just quickly do that. Unlock, just so we can run the script. Here we are, it's just updating, it's just sending it to the blockchain. Okay, cool. So you can now see the total Yieldly unlocked is now equal to the total Yieldly locked, and this is the case because we're just unlocking 100% of the pool at once, which is fine. And for the sake of completion as well, what we'll do is we'll actually just get the user out of the pool completely and see how the staking shares remain the same. And in this context, what this will mean is we'll be demonstrating how, like, despite you having nothing left in the pool after you've withdrawn everything, your staking shares will stay there until you decide to claim your reward. So it doesn't actually go anywhere. So we'll skip through all of the stuff that you've seen before. So yeah, we see the global staking shares have updated as they should because they update before the amounts update. So yeah, they've updated to the correct amounts here, and now the user still has 100% claim of the pool. So now we're going to step through the claim function, and instead of going through it step by step, we're going to focus more on the actual calculation of it. So let me just we don't want to claim everything. We want to step through it. So let me just quickly modify that. Beautiful. Okay, so for some reason, it doesn't seem to let me jump there, even with a breakpoint. So we'll just quickly do this just to get to the function. And here we are. All right, so as you can see, it pretty much updates in a lot of the same ways the staking and withdrawing one does. The main thing that we want to look at here is actually when it starts to update the global staking shares. So let's just skip down there. All right, so this is the reward calculation. So pretty much the way that this works is we have to be a little bit creative with how we dealt with this, because you can't, you look at a number as large as how much value has been locked in the pool, which is 50 million, as you can see up here. What you can start to see with numbers as large as this is once you start timesing it by numbers as large as like seconds in a day, if a few days pass, you're going to start to see some pretty large numbers coming out, which will actually start to overflow. So we had to change up the order of operations, because typically the way that people would probably think to do this is you times the amount of user staking shares by the amount of rewards that have been unlocked, and then you divide it by the amount of global staking shares. In this case, this is pretty much almost guaranteed a result of an overflow is for pretty much any large stake, but not even just large stakes, pretty much anyone if you waited long enough. So the way that we worked around this, and one of the creative ways we worked around this was we just simply changed the order of operations a little bit. So what we did was we essentially get the total Yieldly that is unlocked. We grab that value. We then grab the amount of global staking shares and the amount of user staking shares. Perfect. We load them onto the stack. Then essentially what we do is that we divide the amount of the amount of global staking shares by the amount of user staking shares, which in this case will result in a 1. But in the real context, it's going to be a completely different number. We then divide this number we then divide the amount of Yieldly that is unlocked on the that has been unlocked by this number that we have just gotten from this division here, and then we get the amount of rewards that this person's entitled to, which in this case is 100% of the pool. We then store this value, load it from the space, and then we basically, because it's a group transaction, because right now with TEAL in its current state, you can't make a direct call on the blockchain through the TEAL contracts as of right now. But from what I understand, that's actually due to change. But for now, what you have to do is in the second transaction, you have to specify how much you wish to claim as well. So we just do a basic check to make sure that that amount has to be greater or equal than the amount that you're asking for. Otherwise, it'll fail, and then it'll move on. So that's pretty much how this staking reward system works in a nutshell. For the sake of time, we'll start to wrap up this demo a bit more and start to get move along with the slides. But I'm hoping that you guys have now gotten the general idea of how the Yieldly staking pool system and the Yieldly reward systems work and how they're ingrained into the TEAL smart contracts. So this entire demo will actually be available to you guys. I'll make a public repo available so that with the demo code, so that you're able to just pull it and have a little bit of a play of it and sort of see how we did it. So I'll make that available to you after this demo. So that's all well and good. So let's focus on the here and now. And basically, let me tell you guys. All the issues that we face conceptually with TEAL 3 is just not an issue with TEAL 4. So I have nothing but praise to the Algorand team for all of their contribution for the release of TEAL 4. So let's get stuck into some of the reasons why it's actually so great. So first and foremost, let's just address some of the fixes that TEAL 4 has brought to the table. I know they have an office hours from a few weeks prior that everyone can get on board and read into. So I won't give too much of a detailed breakdown into AVM 0.9 in TEAL 4, but instead I'll just focus on some of the core things that they've released and made our lives just a little bit easier with for developing on the blockchain, which I'm sure both new and existing developers with TEAL will appreciate. So first, it's just the contract size limits. It's pretty self-explanatory. Bigger contracts equals more complex logic and less of the problems that we had to do with all the contract splitting. So 512-bit numbers. So all the issues that we mentioned before of overflows, it's not really an issue now with numbers as large as this. Recursion. So basically, when Jason told me that recursion was going to be introduced into TEAL 4, nearly jumped out of my chair with joy. I can't even begin to explain how much of a difference it's already made in our contracts for all of our current development, but you'll be able to start to see that as we talk about that in a bit. So what does this mean for TEAL? Well, just overall, it's just going to create just a better ecosystem for developers all around. They won't have to deal with a lot of the frustrations that we had to with TEAL 3. The Algorand team has taken on board a lot of our feedback. I feel in releasing all these updates, and I really feel like they're taking a developer-oriented approach in making sure that they're providing the tools necessary for us to build some pretty incredible things on the Algorand ecosystem. So what's next for Yieldly, and what are we going to offer now that we have the power of TEAL 4 available to us? So let's just start to get into that. So basically, the first thing that we're going to get into is the next generation of staking pools. So as I said earlier, we're working pretty hard and early on the next generation of TEAL 4 contracts. And basically, the first that we're going to be releasing is the next generation of staking pools. So I'll briefly go over some of the newer features that we've introduced into our staking pools new contracts. And yeah, so basically the first is is multiple token staking pools. So now we're going to be able to have token to, one reward token and one staking token and a different reward token available for collection. So that's just one of the changes that we're making, or one of the pools that we're going to start making available to Yieldly, to the Yieldly ecosystem and the Algorand ecosystem. Same token staking pools, much like our existing Yieldly staking pool, is now going to come with an auto compounding reward scheme, much to hoping to everyone's joy. It was a big piece of feedback that people have been giving us, and we're really hoping to deliver with that. No strange time unlocks and accrual of rewards. So basically, for every second that you're participating, the rewards are being unlocked and accrued into your account. So that means that there's going to be no loss of rewards, which means that there's going to be no vague language like it's not yours till you claim, that sort of stuff anymore. So yeah, we've been working very hard behind the scenes on some new math and some new staking pool logic. And yeah, based on the testing that we've already done, it's already very, very promising. And also, more importantly, being able to claim pretty much at any time. No weird arbitrary, waiting time limits for like 24 hours for your user state to unlock. For your user state to update. None of that stuff really anymore. Okay, so I have two slides which demonstrate some of the examples of how we're improving our contracts. I'll briefly go over just some of the improvements that we made. So basically, it's one of the first improvements that you can see is just 512-bit number utilization. So the way that we're using this is, as you can see over here, with the precision variable in the image. Don't worry, these slides will be available to you. You can zoom in and have a look at what we're doing. But basically, we're trying to utilize 512-bit numbers to their I guess their full capacity. So this will allow us to do much higher precision mathematics, which is definitely something that was, I would say, distinctly lacking in our early contracts with some of the limitations that were imposed, but now no longer a problem with TEAL 4, which is fantastic. So also, this is also just a little sneak peek into one of our new reward schemes that is being implemented. So this one is the tokens per share rewards system scheme. So we're taking inspiration from other platforms such as PancakeSwap. And basically, this is going to be like one of the first of many of our multi-token staking pool reward distribution schemes. So keep an eye out for that. Some more stuff to come there. And on the second slide, basically, this is going to show how we use recursion inside of our own contracts to help improve security. So you can call this one a bit of a freebie, but basically, what this does is it just loops through. It just loops through based on how many transactions are on a group, and checks some of the key things that you're definitely going to want to check in a group transaction, which is make sure that people can't rekey, checking the close remainder twos and the asset close remainder twos, and making sure that people aren't doing nasty things to your escrow to steal funds from it or anything like that. So this is one of the many innovations that have now come thanks to TEAL 4. Which we're now capable of doing, which helps reduce our code base significantly. So yeah, if you want to see more information on this, I would definitely go recommend watching the developer office hours that they've done. I think it was just over a month ago, where they talk about AVM 0.9 and TEAL 4. It's definitely worth the watch. So I'm sure this is one that many fans of Yieldly and indeed the Algorand as a whole is waiting for, and it's an automated market maker product in Algorand. So Yieldly aims to provide the best products on the Algorand ecosystem, and there's no better way of solidifying ourselves as one of the greats on the blockchain, on this particular chain, than delivering a product such as an AMM. Because we want to bring a fully fledged decentralized decentralized trading to Algorand to help enable our users to provide assets to reserve and receive liquidity pool tokens in return. And we're hoping to introduce ways to incentivize the provision of liquidity. So ultimately, what does Yieldly aim to bring to the plate? The first is bringing decentralized trading to Algorand. The second is providing the means to provide assets to the reserves and receive liquidity pool tokens in return. And the third is incentive programs for people who provide liquidity in various other parts of our product suite. So, like, what is Yieldly if you're not using those tokens to earn more yield? So, with the aim of bringing decentralization to Algorand and creating more versatility of our products, we're taking this approach very seriously, which is why we're taking a bit more of a methodical approach to this particular product than others that we've done in the past. So what this generally means is that we're working very hard in the background to, drawing up all the user flows, the functions, variables, everything on paper, nice and early, and working very closely with our auditing partners to every step of the way to ensure that we're building a safe and secure set of contracts for that. The next is we're going to be introducing beta testing. So we're for the first time for Yieldly products, we're basically going to be opening up our platform for beta testing, in this case specifically for the AMM. That's because as true believers in DeFi, our harshest critics other than ourselves is definitely going to be our users. So we wish to bring a strong, tight, and secure experience for our users. So, especially a system as critical as this, we really wish to put our best foot forward and be as proactive as we can. And also, we're going to have multiple contract audits on this because, as we can imagine, it's probably going to hold a lot of liquidity, hold a lot of tokens. So we want to make sure that we've had the best eyes on it and have no holes, leaks, or anything even possible on these types of contracts. And lastly, not really discussed here on our slides, but basically we're going to be introducing a bug bounty program. So for people who are quite tech savvy and want to really get into the nitty gritty of it, we're going to introduce a tiered leveling system for rating our bugs and providing an appropriate bounty for that. So that could range from anything from a few $1,000s to even historically for Yieldly has led to contractual employment to help secure and consult our systems. So there's definitely a lot of good use cases for smart all the smart tech heads to look at our system, try and break it, and we incentivize strong goodwill characters to come forward and tell us about it, and we will reward that in kind. So here's a general timeline of when we're expecting to release everything. The timeline is fully released on our website as well. So if you're interested in that, I would recommend you go and take a look at that. But essentially, to summarize, Q3 of this quarter, we're expecting to release our first partner staking pools. In Q4, we're basically going to be introducing our next generation of TEAL4, streamlined TEAL4 contracts for our staking pools, as well as a range of other products. And Q1 of 2022 is where we're aiming to release our AMM to the mainnet. So some exciting things to look out for there. All right, so thank you for listening, everyone. It's been a pleasure presenting to you. Hope I haven't been rambling on for too long. The QR code here just simply links to our presentation where you can grab the slides and have a more detailed look through them in your own time.
Thanks so much, Aaron. That was just a wonderful presentation here today, explaining all the different product suites that Yieldly are building on the Algorand protocol. Wonderful demos that really spoke to our developers about your design choices, why you designed your TEAL in the way that you did, the limitations that you found with TEAL 3, and now how you're looking forward to building new solutions to overcome those with TEAL 4, TEAL 5 as those come out with the ABM 0.1 and 1.0 in the very near future. So thank you very much. Remind us once again where we can connect with you, your project, where we can see some of that sample code.
Yeah, cool. So pretty much you can go to our Telegram. We're pretty proactive of reading through that. So we've always got our eyes on that. So if you're commenting on the Yieldly main chat, we'll see a lot of your comments there, or at least we'll be told if we got any questions there. I also try to frequent the Discord as often, the Algorand official Discord as often as I can. So if any questions pop up there that I feel like I'm inclined to or able to answer, I'm always more than happy to do so there. As for the code and everything else, what I'll do is I'll wrap up this demo in a nice little package, and then basically what I'll do is I'll make it publicly available, and I'll probably just drop it around either on the Telegram chat or the Discord chat.
Well, with that, thanks very much for joining us here on Developer Office Hours. Take care and have a good rest of your day, Aaron.